All right, plan for today, plan for this recording is to learn a topic called Complete the Square. Before we do that, we do need to go back and just take a second, more than a second, take a few minutes, and let's do a warm-up problem. Since I'm not here, I can't really put a warm-up problem on the board. So let's do this warm-up problem. If you have a piece of paper, go ahead and do it. It's not on your notes. It's just a warm-up problem. Grab a whiteboard, whatever you need to do, hit pause, get yourself a whiteboard, get yourself a piece of paper, and then give this problem a try. Once you're done, come back, unpause it, and I will talk through it. All right, so hopefully you did that and you have something written down. If you don't, I highly, highly encourage you to hit pause again and go back and get as far as you can get. Don't just wait for me to do this problem. You really need to make sure you can do it. Okay. Vertex. You should be able to look at this and see my vertex is -2. It went left 2 and up 5. So my vertex is a -2, comma 5. Axis of symmetry. It's always just the same x coordinate as my vertex, but it's an x equals equation. All right, going over to my graph, -2, +5. I need to extend that up a little bit. Let's go here. Let's just drag that up a little bit. Whoops. Make myself a new x coordinate. So 1, 2, 3, 4, 5. So -2, +5. My vertex is sitting somewhere right around there. There's a negative sign in front, so I know it opens down, and there's just a 1 in front. So I would highly encourage you just to graph it right now, and then we will see how many of these key characteristics my graph tells me. So I'm going to go over 1 and down 1 in both directions. Over 2, 1, 2, and down 4 in both directions. And I get my graph, whoops, my graph cruises up something like this, curves, and comes down, passes through that point, and on down. So there's my graph. So what did I get from the graph? Well, I got my y-intercept. It looks like it's supposed to be, that's a 1. It should be 0, 1, not x-intercept. My y-intercept is 0, 1. Now, let's just say I couldn't get that from the graph. The other way is I go back up here and I put in 0 for x. So y equals -0 plus 2 squared plus 5. 2 squared is 4. The negative makes that a -4 plus 5 does give me a value of 1. So my y-intercept really is 0, 1. Okay, x-intercepts. Well, that was not so easy. Looks like my x-intercept's a negative, what, 1, 2, 3, 4 point something, and somewhere between 0 and 1. I can't get this from my graph. So I'm going to put 0 in for y, right? That's why I find the y-intercept, or sorry, x-intercept. Let me get rid of this up here. I'm going to put in 0 for y now. So 0 equals negative x squared, or x plus 2 squared, plus 5. We're back to 2 days ago. I'm going to subtract 5 from both sides, just like we did in the first topic of this new section. Divide by whatever's in front of here. I have a -1. I can't square root right now. I have to get the x squared term by itself. There's a -1 sitting here. So I'm going to divide both sides by that -1. That goes away. That goes away. -5 divided by -1 is a +5. And that is x plus 2 squared. Square root both sides. And when I do that, I generate the plus and the minus. Grab a calculator, type in the square root of 5, and you should get 2.24-ish. And so that equals x plus 2. Right? Because this square and square root goes away, and I'm just left with x plus 2. Or -2.24 equals x plus 2. Subtract 2 from both sides. Subtracting 2 from this gives me 0.24. Subtracting 2 from this gives me a negative 4.24. Looking at my graph, negative 4.24 looks good, and a positive 0.24 looks good. Let's write these like they're supposed to be. XY coordinates. And now I have my information that I need. I have all that stuff filled out, and I have my graph. Compare. It's just simply left 2. I just write in words how this graph is different than y equals x squared. It's left 2. It is up 5. And it is upside down. The phrase I used earlier was transformations. Transformations and compare is the same thing. Okay, so that should be all review. Hopefully it went well. If not, you need to say something before we get to the test. All right, today, you should have a piece of paper or this note paper in front of you. If not, make sure you get one. Sub should be handing all those out to you. And this is your notes and your homework. So last class period, I gave you a big old packet for notes, then I gave you another worksheet for your homework. That's not true here. This is everything. Okay, this is your notes and your homework. Okay. We're going to complete the square. And what that means is we are going to try to factor an expression or change an expression so that we can factor it to look like something like this. Just like when we factored, you have to be able to go forward before you can go backwards. So get really used to what's going to happen here. You're going to hit pause and you're going to do these problems. Okay, that's what's going to happen on this whole entire lecture today. You're going to hit pause, try a problem, then I'm going to then come back and so on. Okay, so get comfortable hitting pause and engaging and doing some work. Okay, so take a second or two and multiply all 3 of these together. Okay, so hopefully you hit pause. If not, hit pause and try them, then come back. So if you've hit pause and you're back, what does x plus 2 squared mean? It means multiply x plus 2 times another x plus 2. So I'm going to go x times x. Not sure what it's doing. Get rid of that. Quit it. There we go. All right, sorry. A little glitch in my program. All right, so we're going to go x times x, which is x squared. We're going to go x times 2. We're going to go 2 times x. And 2 times 2. Combine like terms. And I get x squared plus 4x plus 4. My goal is to be able to answer this question here. With just one expression, pretty hard to find the pattern. We need to do a few more. So do this one. Hopefully, again, you've done all of these. If not, stop and do these. If you don't do them, it'll be just me telling you what the pattern is, and that's not near as helpful as you seeing the pattern by actually doing the problems. Same thing, x times x, x times a negative 3, negative 3 times x, negative 3 times a negative 3. Combine like terms. And we have our expression multiplied out. Last one. X plus 4 times x plus 4. X times x. X times 4. 4 times x. And 4 times 4. Combine like terms. Okay. Our goal is to be able to find a pattern, some relationship between this number here and this number here. Hit pause. See if you can see a pattern between these two numbers and between the work that we did to get these two numbers. That will help you. Once you think you have a pattern, if I gave you x squared plus 12x, what would you add to this so that you come up with an expression that can be factored into two terms that are the same, so I can write it as something squared? Our goal is to be able to go backwards. So I need to figure out, what does this need to look like so that I can factor it into two terms that are the same? I need to do what's called completing the square. I need to add something right here to make this a perfect square, or a term that can be factored into something squared. Okay, once you think you see the pattern, make a guess. What number would you put right there? Okay, if I look at this number here, where did the 8 come from? The 8 came from combining these two like terms. So if I'm given this 8 and I want to go backwards, I would divide by 2 to find out what these two numbers need to be. Okay, where'd those two numbers come from? Came from these two multiplied together. Well, this number here times this number here is what gave me the 16. So if I took 8 and divided it by 2, I would get 4. And if I take that 4 and multiply it by itself, or square it, I get that number there. So if I take this coefficient of x, called my b value, and divide it by 2 and square it, it looks like it gives me this number here. Does that work over here? If I take 6 and divide it by 2, I get 3. Does 3 squared give me 9? Nope. Does 3 squared give me 9? Answer, yeah. Does it work over here? 4 divided by 2 is 2. Is 2 squared equal to 4? Yeah. So the relationship that I see is I divide the b by 2 and square it. Or let me rewrite that a little better. C equals b divided by 2 squared. That's the relationship between these two. This number right here is my b value divided by 2 squared. Okay, so over here, what do you want to add? 12 divided by 2 is 6, and 6 squared is 36. Jump down here. Try 5, 6, and 7. What value for C will complete the square? Will make this an expression so that I can factor it into something like that? Okay, hopefully you've hit pause. If not, hit pause and figure out 5, 6, and 7. Okay, in this case, my C value needs to be 8 divided by 2, which is 4, and 4 squared equals 16. So my C needs to equal 16. Now, factor it so that it's a perfect, so that it, just factor it. We'll end with that. So get rid of all this. So here's my new expression. X squared plus 8x plus 16. Let's factor that. Let's go backwards. Here's what we have. Let's go backwards to here. So I have two parentheses. X times X gives me X squared. What two numbers that are the same multiply together to give me 16? Well, 4 times 4. And they need to add to give me the 8. Well, 4 times 4. So this is a 4, and this is a 4. If this is a plus, then both of these are positive. Notice this number right here is half of that number there. Notice these numbers here are half of that number there. These numbers here are half of that number there. So when you are dividing this by 2, the number you get when you divide by 2 is the number you're going to put into your factors. Well, that makes it easy. 10 divided by 2 is 5, and 5 squared is equal to 25. So I have x squared minus 10x plus 25, and I'm factoring that thing. So I'm going to factor, oh, sorry, I got to go back over here. I'll do it in a second. So I'm going to factor that into x minus 5 times x minus 5. How did I know that right away? Because that number, when I divide it by 2, is always what goes right here. Where'd the negative sign come from? If this is a negative, the signs are both negative. Okay, x plus 4 squared can be written as x plus 4 times x plus 4 can be written as x plus 4 squared. X minus 5 times x minus 5 can be written as x minus 5 squared. And that's our goal, to take this, add something to it to make it a perfect square so that it factors into something like that. Okay, last one before we get down here. X. Oh, sorry, I'm jumping the gun. Divide 5 by 2, and I get 2.5. 2.5 squared is equal to 6.25. So this becomes x squared plus 5x plus 6.25. That factors into x and x. So 2.5, the number I got when I divided by 2, is what goes here. And it's what goes over there. I don't have enough room. And it's what goes over here. If this is a plus, then both of these are plus. And I can write that as x plus 2.5 squared. And that is completing the square. Okay, now we're going to use that to do two different things. We're going to use it to solve, and we are going to use it to switch forms from standard form into vertex form by completing the square. That's the two ways we're going to use it in this course. Okay, solve by completing the square. First question. Is this 5 the right value where I can factor it into something that looks like that? Is the 5 the right number? No. What number should it be? Go back to what we did right here. It should be 6 divided by 2, which is 3, and 3 squared, which is 9. This should be a 9. It's not. It's a 5. So I'm going to get rid of it. How am I going to get rid of it? I'm going to subtract 5 to get rid of it. Well, I can't just subtract 5 from one side. I have to balance it by doing the same thing to both sides. So I subtracted 5 here to get rid of this, and now I subtract 5 over there. That goes away, and I get x squared plus 6x. 0 minus 5 is a negative 5. Okay, now we're right back to what we did up here. What do I need to add to make this a perfect square? Same question as what we just did in 5, 6, and 7. And I already did this for this problem. I divide that by 2, and I get 3. Square it, and I get 9. Well, just like here, I can't just add 9 to one side. So if I add 9 to this side, I have to add 9 to this side. Notice I'm not moving the 9 over. I'm not subtracting 9 now. This 9 was a brand new term. I added it to this side. Just like this is a brand new term. I subtracted 5 from this side. So what I do to one side, I do to the other. I added 9 here, so I have to add 9 here. Okay, right-hand side's easy. 9 minus 5 is 4. This side here factors into x plus 3 times another x plus 3. How did I know that so fast? Because remember, that number there divided by 2 tells me this number. 6 divided by 2 is 3. That number there is the same. That's 3. Whatever sign is here is the same sign in both places. This can be written as x plus 3 squared. And we're right back to what we did over here, right? Remember when we solved this thing? We solved by square rooting both sides. Same problem. We're right back to solving. How do I get rid of a square? I square root. And what I do to one side, I have to do the other. And when I square root a square, I generate the plus and the minus. So x plus 3 could equal 2, and x plus 3 could equal a negative 2. Subtract 3 from both sides, x equals negative 1. Subtract 3 from both sides, x equals negative 5. Done. Solved by completing the square. Okay, hit pause. My guess is going to take you 5 to 15 minutes, depending upon how well you get this. And if you get stuck, pop back in, listen to a problem, and then try the other ones. Don't just listen to me do them all and not do any of these. Could you? Yeah, I know you could. But that's not going to help you. The goal of doing homework is not to get done. The goal of doing homework is to learn how to do it. Hit pause, come back when you're done, or when you need a hint. Okay, number 9. First step. Is this 5 the right number? Nope, I'm going to get rid of it. Leave myself a space because I'm going to add something. Okay, divide the 4 by 2, and I get 2. 2 squared is 4. I added 4 to this side, so I'm going to add 4 to this side. Factor this. This factors into x and x. 4 divided by 2 is 2, so that's a 2. That negative sign makes both of those negative. Remember, this is positive. These signs have to be the same. And whatever sign is here is what that is. 4 plus 5 is 9. Write this as x minus 2 squared because the two expressions are the same. And I'm right back to solving. Square root both sides. I get the plus and the minus. So I write two equations, sorry. X minus 2 equals 3, and x minus 2 equals a negative 3. You have to write both of them. Solving, I add 2 to both sides. X equals 5. I add 2 to both sides. X equals negative 1. Both of these are my answers. Same over here. Number 10. Is that 1 the right number? Nope. Subtract 1 from both sides to get it to go away. Because that's a positive, I'm going to subtract 1 there, and that goes away. What do I need to add here? I take 10, divide it by 2, I get 5. 5 squared is equal to 25. If I add 25 here, I have to add 25 here. This factors into x minus 5 times x minus 5, because 10 divided by 2 is 5, and because 5 times 5 is 25. 25 minus 1 is 24. X minus 5 squared equals 24. I grab a calculator. I take the square root of 24. Square root of 24. And I get 4.89. So x minus 5, I didn't show my work, sorry. Show my work equals 4 point, really it's 4.90. And x minus 5 equals a negative 4.90. Add 5 to both sides, I get 9.90. Add 5 to both sides, and I get negative 0.10. And we're done. Question 11. Is that 7 the right number? Nope. I add 7 to both sides. Let me start over. I'm going to slide down a little bit. We're going to add 7 here. We're going to add 7 here. Give myself a space. Divide by 2. I get 1.5. Square 1.5, and I get 2.25. So I'm going to add 2.25 here, and I'm going to add 2.25 here. Factor this thing. Here's where that, I won't say trick, but here's where the understanding how to find this number really helps. X times x is x squared. Divide this by 2, and that's the number I put here. That'd be a 1.5 and a 1.5. If this is a plus, this is a plus, and this is a plus. Let's just double check. 1.5 plus 1.5 does give me 3. 1.5 times 1.5 does give me 2.25. That's how we got it in the first place. Solve, or not solve, rewrite. Square root both sides. Generate the plus and the minus. The square cancels the square. And x plus 1.5 equals the square root of 9.25, which is 3.04, or negative 3.04. Subtract 1.5 from both sides, and x equals 1.54, and subtract 1.5, and x equals a negative 4.54. Okay, and we have those answers and those answers. Okay. Not a new technique, just a different goal. My goal is to change something that's written in standard form to something that's written in vertex form. If I look at this equation right here, I can see my vertex is a negative 2, 5. If I look at this equation here, I can't see my vertex. I would have to do the x equals negative b over 2a concept and all that work. And that works, but we're looking for a different technique. Okay, so here's what we're doing. Still going to complete the square. But then I'm going to not actually solve after that. Okay, so my first step, is this 1 the right number? No. So do the exact same step. Get rid of it. Subtract 1 from both sides. That goes away. The difference is I can't take this number and actually subtract it. So I'm just going to write y minus 1. Next step, what do I need to add to make this a perfect square? 6 divided by 2 is 3. 3 squared is 9. If I add 9 to this side, I must add 9 to this side. On the left-hand side, I get y plus 8. This factors into x and x plus 3, 6 divided by 2, plus 3. 3 times 3 is 9. 3 plus 3 is 6. I can rewrite this as x plus 3 squared. Whoops. Move the 8 back across, and I get y equals x plus 3 squared minus 8. Now, you should be able to look at that and see the vertex. This makes my graph go left, so my vertex is a -3. That makes my graph go down, so my vertex is a -8. It is always the opposite for the x, the same for the y, and that's my vertex. Write the following equation in vertex form. Done. Whoops, done, right here. And then state the vertex. Wrote it in vertex form, and we stated the vertex. You don't need to solve to find x-intercepts and all that good stuff. Just looking for the equation in vertex form. Your turn. Try 13, 14, 15. If you get stuck, come back and get a hint, then go back to solving. Don't just listen to the whole recording and listen to me do it. Try them first. All right, hit pause. Okay, first step, I'm going to add 3 to both sides because that's not the right number. And I get y plus 3 equals x squared minus 4x. Divide the coefficient of b by 2, and I get 2. And square it, and I get 4. If I add 4 here, I have to add 4 here. Left-hand side becomes a 7. This factors into x minus 2 times x minus 2, which I can write as x minus 2 squared. This didn't change. Move the 7 back across. Final answer, y equals x minus 2 squared minus 7. Vertex, positive 2, negative 7. Opposite for the x, same for the y. Positive 2, negative 7. Opposite for the x, same for the y. Number 14. Add 2 to both sides. Divide the 5 by 2, and I get 2.5, and square it, and I get 6.25. And I'm going to add 6.25. Left-hand side becomes an 8.25. Right-hand side becomes x minus. When I divide this by 2, I got 2.5. And I get another 2.5. There's a point in there somewhere. And so I get y plus 8.25 equals x minus 2.5 squared. Subtract the 8.5. And we're done. No, we're not done. Vertex, 2.5, opposite for the x, and negative 8.25. Same for the y. All right, last one, subtract the 4. Add 3.5, right? 7 divided by 2 is 3.5. And 3.5 squared is 12.25, which means I have to add 12.2525 over here also. This becomes a positive 8.25. This becomes x and x. Factor, or this divided by 2 is 3.5. Since this is negative, these are the same. They're both negative. That factors into x minus 3.5 parentheses squared. Subtract the 8.25. And we have our equation. Right, the vertex. Vertex equals 3.5. Opposite for the x. Same for the y. Opposite for the x. Same for the y. Okay, that's the big chunk of what we're supposed to learn today. Challenge section. This one's going to make you think a little bit. Not a lot. It's not horrible, but it'll make you think a little bit. Okay, the difference between what we have up here and what we have down here is the coefficient of x squared is not 1. And before we can complete the square, the coefficient of x squared must be 1. That's the only step we're adding. It changes some intermediate steps, but that's the big thing that we're changing. So, first question is no different. That -7 is not the right number. It needs to go away. So I'm going to add 7 to both sides. Okay, this becomes 11. Coefficient of x squared must be 1. It's not. So let's divide everything by 2. And it must be everything. If you only divide part of it, it changes the answer. And here's why. If I have 4 plus 6, that equals 10, right? If I divide this by 2, I get 2 plus 6, which does not equal 10. If I only divide the 6 by 2, I get 2 plus 3, which does not equal 10, and so on. Only way that these are the same is if I divide everything by 2, and I get 2 plus 3 equals 5, and that is a true statement. If I'm going to divide something by 2 in an equation, it has to be everything. Okay. 11 divided by 2 is 5.5. 2x squared divided by 2 is just x squared. That's why I did that. 10 divided by 2 is 5. Now, what do I need to add to make this a perfect square? Divide 5 by 2 and I get 2.5. 2.5 squared is 6.25. At this point in time, we're doing nothing different. We're right back to what we started with. Only difference was I have to get that 2 out of there. And I divide everything by whatever's sitting in front of here, even if it doesn't come out to be a nice, neat number. And then I'm back to what I've been doing. Divide 5 by 2, and I get 2.5. Squared, I get 6.25. Add 6.25 to the other side, and I get 11.75. Factor this thing. 5 divided by 2 is 2.5. This negative makes both of these negative. Square root both sides. When I do, I generate the plus and the minus. The square root of 11.75 is 3.35. Or negative 3.35. Add 2.5 to both sides, and I get 8.85. And I get, not 8, I get 5 point. I can't add. Get 5.85. And then over here, I get x equals negative 0.85. I got my 2 answers. Your turn. Try 17. Hit pause. Give it a try. Subtract 5 from both sides. Divide everything by 3. Oh, lucky us. It came out nice and neat. Then we get x squared minus 4x equals 2, because we divide this by 3, and that by 3. Okay, 4 divided by 2 is 2. 2 squared is 4, so I have to add 4 to both sides. Multiply, not multiply, but factor that thing into x minus 2 times x minus 2, which is x minus 2 squared. Square root both sides, and I generate the plus and the minus. X minus 2 equals the square root of 6, which is 2.45. And x minus 2 equals a negative 2.45. Add, x equals 4.45, add x equals negative 0.45. Okay, same technique as we did right above here. Finding this, changing this to vertex form. The difference is we have a coefficient of x squared. Just like before, though, my steps are the same. I subtract 5 from both sides. I'm going to factor out that 3. That's the difference. Up here, we divided everything by 2. I don't want to divide that by 3. That's going to be a mess. So I'm not going to divide everything by 3. I'm going to factor it out. And before I do it, I'll just rewrite what I have. Okay, I'm going to factor a 3 out of both of those. Not a 3x, even though there's a 3x common. I'm just going to factor out the 3. 3x squared divided by 3 is equal to x squared. 6 divided by 3 is equal to 2. Ignore everything else but just this right here, and we're going to complete the square, just like we did above. Divide the 2 by 2, and I get 1. 1 times 1 is 1. Now, here's the tricky part. This 1 is inside of a parentheses with a 3 out in front. This 3 will distribute to all 3 terms. When I multiply 3x times x squared, I get 3x squared. When I multiply 3x times a negative 2x, I get negative 6x. All good so far. 3 times 1, though, gives me a plus 3 right here. When I added this 1, I really didn't add 1 to this side of the equation. What I really added to this side of the equation was that 3. So now when I balance the equation, I don't add 1 over here. I need to add 3 over here, because this 3 makes this 1 a 3 when I distribute it. Left-hand side is a negative 2. Leave the 3 alone and factor that inside expression. What does that factor into? X and x. Factors of 1 are 1 and 1, or 2 divided by 1 is my 1. And it's a negative because there are negative signs here. Y minus 2. X minus 1 can be written as x minus 1 squared. Add the 2 to the other side to get it back over there, so I have my vertex. What's my vertex? Opposite for the x, same for the y. And there's my vertex. Hit pause, try number 19. Okay, taking the 3, moving it over here, becomes y minus 3. The coefficient of x squared this time is a negative 1, so I'm going to divide out a negative 1. That becomes x squared. The 4 was positive, now it becomes a negative 4x. Leave myself a space. And 4 divided by 2 is 2. 2 squared is 4. Added 4 here, but this negative sign gets multiplied by that 4, so what I really did over here is I added a negative 4, which means I have to add a negative 4 over there. That becomes minus 7. This becomes x minus 2 times another x minus 2, which I can write as x minus 2 squared. So y equals a negative x minus 2 squared plus 7. Whoop. Vertex is at 2, 7. Opposite for the x, same for the y. All right. My guess is you're very close to the end of the hour, if not already at the end of the hour. If you are at the end of the hour, to behave for the next few minutes, and you are all done and good to go. Hope that helped.